Correlation and regression analysis. The product moment correlation, or R, summarizes the strength of association between two metric variables. That means two variables that are scaled on an interval or ratio scale. It is an index used to determine whether a linear or straight line relationship exists between variable x and variable y. In this example, territory sales and number of salespersons. The correlation coefficient gives us an idea of whether there is a systematic linkage that is consistent between the levels or labels of these two variables. This linkage is statistical, not necessarily causal. A causal linkage is one in which one variable has certainly affected the other. But with a statistical linkage, the relationship is not certain because some other variable might have had some influence. Nonetheless, statistical linkages or relationships often provide us with insights that lead to understanding, even though they are not cause and effect relationships. Once again, it's important to note that to use correlation, both variables must be metric, meaning they are measured on an interval or ratio scale. To examine important marketing research questions, such as how strongly are sales related to advertising expenditures, or is there an association between market share and size of the sales force, or are consumers' perceptions of quality related to their perceptions of prices, we would use the product moment correlation, which is called R. This is the most widely used statistic for summarizing the strength of association between two metric variables. From a sample of n observations, x and y, the product moment correlation is calculated using the formula you see on screen. In these equations, x bar and y bar denote the sample means, and s sub x and s sub y are the standard deviations associated with variable x and variable y. COV sub x sub y is the covariance between x and y, which measures the extent to which x and y are related. The covariance may be either positive or negative. Division by s sub x and s sub y achieves standardization so that R varies between -1 and +1 every single time. Note that the correlation coefficient is an absolute number and is not expressed in any unit of measurement. The correlation coefficient between two variables will be the same regardless of their underlying units of measurement. Because R indicates the degree to which variation in one variable is related to variation in another, it can also be expressed in terms of the decomposition of the total variation. In other words, R squared equals the explained variation divided by the total variation. In other words, R squared measures the proportion of variation in one variable that is explained by the other. Both R and R squared are symmetric measures of association. In other words, the correlation of x with y is the same as the correlation of y with x. It does not matter which variable is considered to be the dependent variable and which is the independent. The product moment coefficient measures the strength of the linear relationship and is not designed to measure nonlinear relationships. Thus, R equals 0 would simply indicate that there is no linear relationship between x and y. It would not mean that they are unrelated. There could be a nonlinear relationship between them. When it is computed for a population rather than a sample, the product moment correlation is denoted by the Greek letter rho. The coefficient R is an estimator of rho based on a sample. Note that the calculation of R assumes that x and y are metric variables whose distributions have the same shape. If these assumptions are not met, R is deflated and underestimates rho. In marketing research, data obtained by using rating scales with a small number of categories may not be strictly interval. This tends to deflate R, resulting in an underestimation of rho. The statistical significance of the relationship between two variables measured by using R can be conveniently tested. The hypotheses are: the null is that the correlation equals 0, meaning that there is no linear relationship, And the alternative hypothesis is that the correlation is not zero, meaning that there is a linear relationship. The formula for the test statistic is shown here on screen. It is a t-statistic, so it has a t-distribution with n-2 degrees of freedom. After computing the test statistic, we would obtain the critical value to compare the test statistic with from the t-distribution table. The critical value of t for a two-tailed test, an alpha level of 0.05, is 2.228. However, SPSS provides a quicker test, which we will examine in just a moment. After we have established that a correlation coefficient is statistically significant, we can talk about some general rules of thumb concerning the strength of association. Correlation coefficients that fall between +1 and +0.81 are generally considered to be strong. The same applies to -0.81 to -1. Those correlations that fall between +0.8 and +0.61 or -0.61 and -0.8 are moderate in strength. Those that fall between +0.41 and +0.6 or -0.41 and -0.6 are weak. And thereafter, the correlations are either very weak or there is considered to be no relationship. So the correlation coefficient's size indicates the strength of association between the two variables, and the positive or negative sign indicates the direction of the association. As you use these guidelines, remember, we are assuming that the statistical significance of the correlation has been established. And secondly, researchers make up their own rules of thumb, so you may encounter someone whose guidelines differ slightly from those in this table. In any case, it is helpful to think in terms of the closeness of the correlation coefficient to 0 or to positive or -1. Statistically significant correlation coefficients that are close to 0 show that there is no systematic association between the two variables, whereas those that are closer to positive or -1 express that there is some systematic association between the variables. When there is an association, the p-value for the Pearson R will be less than or equal to 0.05. A scatter diagram would demonstrate also the direction of the relationship. Graph B shows a negative relationship, which would also be manifested with a negative R value. Graph C demonstrates a positive association, which would be demonstrated through a positive R value. The negative association would indicate an inverse relationship in which as one variable increases, the other decreases, or vice versa. The positive association would indicate that both variables covary in the same direction. So if one variable increases, so does the other, and if one variable decreases, so does the other. Can you think of some variables that have these types of associations in marketing? When there is no association, the p-value for the Pearson R will be greater than 0.05. Here we see a scatter diagram that demonstrates no association. As you can see, the points are just scattered everywhere, and there's no direct linear relationship to be seen. A nonlinear relationship would also result in an R of 0. Correlations will not detect nonlinear relationships between variables. Here there is an inverted U relationship, however, the correlation test will not detect it. Next, I will conduct a demonstration of how to use SPSS to conduct a correlation analysis. Here we see the basic steps involved: selecting Analyze from the SPSS menu bar, clicking Correlate and then Bivariate. We will move the attitude variable and the duration variable into the variables box. We will check Pearson under correlation coefficients, check one-tailed test under test of significance, and check flag significant correlations before clicking OK. This SPSS demonstration is based on the sample data provided in Chapter 17, explaining attitude toward the city of residence. Our variables are the respondent's number, attitude toward the city, duration of residence, and importance attached to weather. First step, select Analyze from the SPSS menu bar. Click Correlate and then Bivariate. Move Attitude into the variable box, then move Duration into the variable box. So in this case, we are interested in examining the relationship between attitude toward the city and duration of residence. Next, we check Pearson under correlation coefficients, one-tailed test of significance, and flag significant correlations. Then we click OK. Here we see the SPSS output associated with the demonstration I just conducted. The correlation between attitude and duration is shown here, and we see that it's 0.936, and the two little stars indicate that it is significant at the 0.01 level. So the P is less than 0.01, which is certainly less than our 0.05 alpha level. Here we see the significance level, the p-value of 0.000. Again, comparing that to our alpha level of 0.05, we would reject the null hypothesis of no association between attitude and duration. And because of the size of the coefficient here, we would see that it's a strong relationship, and the positive sign indicates a positive relationship, meaning that as duration of residence increases, so does attitude toward the city. A related type of analysis of association between two metric variables is partial correlation, which measures the association between two variables after controlling or adjusting for the effects of one or more additional variables. The equation is shown here on screen. Partial correlations have an order associated with them. The order indicates how many variables are being adjusted or controlled. Think back to our ANCOVA discussion. It's the same exact concept. The simple correlation coefficient R has a zero order because it does not control for any additional variables while measuring the association between two variables. When controlling for one additional variable, we have a first order partial correlation coefficient. When controlling the effects of two variables, it's a third order effect, and so on. This statistic is used to answer questions such as, how strongly are sales related to advertising expenditures when the effect of price is controlled? Is there an association between market share and size of the sales force after adjusting for the effect of sales promotion? And are consumers' perceptions of quality related to their perceptions of prices when the effect of brand image is controlled? Just as with simple correlation, SPSS provides a way of conducting a partial correlation analysis. Now I will demonstrate with SPSS how to conduct a partial correlation analysis. To continue our example, suppose the researcher wanted to calculate the association between attitude toward the city and duration of residence after controlling for a third variable, importance attached to weather. We would click Analyze, Correlate, Partial, and then we would enter attitude and duration as our main variables, and then we would be controlling for importance. One-tail test of significance, display actual significance level, and click OK. Now, focusing in on the cell that contains our correlation between duration and attitude, we see a correlation of 0.939, a p-value of 0.000, which is less than our alpha level of 0.05. So we would conclude that there is a significant association between these two variables after controlling for the effect of the third variable.